All right, hello. Today we're going to do quadratic functions specifically and all their properties. More importantly, just basically the properties of their graphs. Um, so here we have the standard form of a parabola, ax squared plus bx plus c. And then this one right here is called the vertex form. Okay, and it's pretty straightforward. You guys know that the parent function is a parabola. That's what we talked about last unit. Looks something like this. And currently the vertex, which is the lowest point, is at 0, 0. Okay, and we also learned last unit that if we subtract in the parentheses, that shifts things to the right, h, which is this coordinate. And if I add k at the end of the equation, then that's going to shift everything up. So that's where this hk come from. The vertex starts at 0, 0, but then there's some shifting, and so the vertex would just be the opposite of this for the x-coordinate, which is just positive h, and then k is going to be the y-coordinate of the vertex. And that's always going to be the lowest or the highest point, depending on which way the parabola opens. Okay? Now, the axis of symmetry is a vertical line that splits the parabola in half, so that on either side you would get the same exact shape. Now, if things are shifted, so let's say I have a parabola that maybe looks like this, and here's my vertex, hk. I still have the axis of symmetry splitting the parabola in half, but now the equation is going to be x equals h, whatever the x-coordinate is for the vertex. Over here, it's x equals 0, because it's just the y-axis there. Here, if we shift, then we follow the shift, and now the axis of symmetry is x equals h, which is recapped right here. Okay. Domain and range should be pretty straightforward. Domain is always all real numbers for parabolas, and the minimum, or the range, I'm sorry, is going to depend on which way the parabola opens. If the parabola opens up, then it's going to be the y value to infinity. If it opens down, then it's going to be the negative infinity to whatever the y value is, okay, which is recapped here. Okay, and this is an error. It should actually be brackets for the k values. Those are not holes, those are actual parts of the graph. So that's a typo there. Okay, so let's just do a couple of examples. One, which is fairly straightforward because it's already in vertex form, so we could answer a lot of this. So first, we know from experience, if this is a positive number, it opens upward. If this were a negative in front, we know that that's a reflection, so it opens downward. So if you see positive, it opens up. If you see a negative, then it's going to open down. Okay. The vertex looks like we're at positive 3 and then negative 6. So I'm going to put that on the graph. 1, 2, 3, negative 6. There it is. The axis of symmetry, remember that that's going to go straight through the vertex. So the equation for that is going to be x equals 3. And now I'm going to sketch the parabola using the rules and transformations that we learned last unit. So first, there's a stretch. Since there's a 1/2 in front of the function, or I guess this would be a shrink, but essentially it's going to be the y values all times 1/2. And then this means we're going to shift right 3 and then down 6. So that's the second thing we would do. Right 3, down 6. So if I follow that, here are the normal points of the parabola. 0, 0, 1, 1, 2, 4, and then same thing on the other side. The first step is that we want to cut those y values in half. So if I take y, all the y coordinates, and multiply them by 1/2, this point that's up at 4 now goes to 2. This point that's up at 1 is now going to go to 1/2. Same with this one, and same with that one. And so currently, after I multiply by 1/2, I have a parabola that looks something like this. The second thing I'm going to do is move all these points right 3 down 6. So if I take vertex and go right 3 down 6, there it is. If I take this point that's at 1, I'm going to go right 3, so I'm going to be at 4. I'm going to start at positive 1/2 and then shift down 6. So now I'm going to be at negative 5.5. Same thing on this side. This point that was up at 2, if I shift right 3 and then down 6, is now going to be at negative 4. And so here's what my parabola looks like. Okay. Axis of symmetry is x equals 3. Here's my vertex right here. Is at negative, oops, I meant 3, negative 6. That's the vertex. Okay. So there's D. What is the y-intercept? Well, I can't really tell from the looks of my graph because it's not the greatest graph. But I remember that to find a y-intercept, you could always plug in x equals 0 to figure it out. So if I take 0 and plug it in to the equation, I get 1/2 times 0 minus 3 squared minus 6. Negative 3 squared is going to be 9. 9 times 1/2 is 4.5. I subtract 6. I get negative 1.5, which looks reasonable for my picture. So the y-intercept is at 0, negative 1.5. Okay, the x-intercepts. Again, I can't really tell what points these are going through. So we could always plug in y equals 0 and then solve. So if I take this equation, set it equal to 0, and then do 1/2 x minus 3 squared minus 6, since I can move stuff around to get this 1x by itself, I'm going to do that. So first I'll add 6. And then, that 1/2 is still there. To get rid of the 1/2, you can double or multiply both sides by 2. So now I get 12 equals x minus 3 squared. And now to get rid of the square, you're going to want to square root both sides. So that gets you plus or minus 2 root 3 equals x minus 3. And the final step would be to add 3 to both sides. So it'll be 3 plus or minus 2 root 3 equal to x. So those are your two x-intercepts. 3 plus or minus 2 root 3 comma 0. And again, you might have to split those up on my math lab. If it asks, then just do the plus first and then do the minus coordinate second. Okay. The rest of it should be pretty straightforward. The domain, again, for any quadratic, any parabola is always all real numbers, so negative infinity to infinity. The range, our lowest point is at negative 6 for the y value. And since the parabola opens upward, we just go up to infinity. Okay. Increasing and decreasing, again, this is a review from last unit. Remember, these are x intervals. We always list x values in interval notation. So increasing, I would say that it's increasing from x equals 3. So from this point on, so from 3 to infinity, f of x is increasing. It's decreasing, though, all the way until we get to 3. So that would be from negative infinity to 3. Okay? All right. And now the last thing we're going to do is this last example. How do we find all these details out when it's not in vertex form? So you may not be able to look at this equation like we did the last one where did I put that? Oh, the last one, we looked at this and said, oh, that's just an x-coordinate of 3 and a y-coordinate of -6 for my vertex, because it's in vertex form. When it's not in vertex form, one way to put it in vertex form is to complete the square, which we talked about in the first section. But there is a shortcut, okay? And we're going to utilize this shortcut a lot, actually, to find the vertex for graphing and for all the other applications that we'll do. The shortcut, and this should be review, is to do the opposite of b over 2a. That always gives you the x-coordinate of the vertex. Just remember that. Okay? This just means now that whatever you get for x, you're going to plug it into the function, and then that's going to be the y-coordinate. Okay? So for this last example, I see a negative in front, so that tells me that it's definitely going to open down. The vertex, I don't know by looking at it, but if I follow the shortcut, the opposite of b, that's going to be +4, divided by 2 times a, which is -1. I'm getting a x-coordinate of -2. Well, to find the y-coordinate, you can now take -2 and plug it in. So y is going to be the opposite of x, which is -2 squared minus 4 times -2. And so that's going to be -4 plus 8. And so -4 plus 8 is 4. Okay? So if I go to -2, and then 1, 2, 3, 4, there's the vertex right here. And this parabola, since there's no number in front besides this 1, there's not a half or a 2 or anything like that in front of the x squared, it's going to have the same exact parent graph shape. So if you remember that the points are 1, 1, and then 2, 4, just opening downward, you can fill in the parent graph shape and then fill in the graph. So here is the parabola. Axis of symmetry is right here at x equals the x-coordinate, which is -2. So x equals -2, vertex is -2, 4. Sketch the parabola, I did that. The translation, well, it's really just a reflection over x, and then it's a shift left 2 and up 4. Now the y-intercept, again, if the graph is good and it's easy to see, you can just look at it and say it's 0, 0. Same with the x-intercepts. 0, 0 is one of the x-intercepts, and it looks like -4, 0 is the other one. Okay? Otherwise, you do what we did in the last example. You can plug in x equals 0 if you need to. To find the y-intercept, here you would plug in y equals 0 to find the x-intercepts. Oh, that should be over here. Okay, domain and range. So domain, as always, for parabolas is all real numbers. The range, this is opening downward, so we're going to start at -infinity and go to the highest y value, which is 4. So it's -infinity to 4. And now it's increasing from the start of the graph all the way to x equals -2. So that's from -infinity to -2, we are increasing. And then from -2 and on, we are going down. So that's from -2 to +infinity. Okay, so that's kind of your lesson today for graphing and looking at the quadratic function properties via graphs. Alrighty, so now you should be able to complete through so 1.2, 1.3, and now maybe start a little bit of 4.3. We didn't finish 4.3, but we'll finish that when we come back. Alrighty. Have a good day.